Hello everybody, welcome back to another edition of Algebra 2. It's Mr. Anderson here with you, and we're in Chapter 6, and we will be in Section 1 of Chapter 6. We're talking about operations on functions. Okay, so let's just get right to it. Take a look at our objectives. So first of all, we want to find the sum, the difference, the product, and the quotient of functions. Remember, sum is addition, difference is subtraction, product is multiplication, and quotient is division. And then we want to find the composition of functions. Okay, and that's some new stuff there. Alright, so first of all, operations on functions. Here's kind of the overview. I'll explain that and we'll do a few examples here. This really isn't too bad. Alright, so basically you notice, here's the thing that's the toughest to get used to is just kind of the notation of it. Okay, so for addition here, they write it like this. You can see it looks like this. You would say f plus g of x is how you'd say that. Really what that means is, and they spell it out pretty good here, it's really you take the f of x function and add it to the g of x function. So you just add those two functions together. You can see here if f of x is 2x and g of x is negative x plus 5, you just add those two together. Combine the like terms. We've done that before. So really this is nothing new. The notation's a little new, but not really anything that different from what we've done before. Alright, subtraction, same thing. F minus g of x. It just means take one and subtract the other one. Remember, in this case, if you have 2x minus a negative x plus 5, remember you have to distribute that negative there, okay? Multiplication, f times g of x. You're just going to take 2x times negative x plus 5. In this case, you will distribute the 2x. Sometimes if your functions, maybe if both your functions are binomials, you might have to FOIL it. And so forth. So you're just going to multiply like you normally would. The only thing that maybe you haven't really noticed before is the division. All you're doing here is you're going to just take the f function and divide it by the g. And so you have 2x over negative x plus 5. Pretty simple. The one thing that's a little different here is, remember, when you have a fraction, we cannot have a 0 on the bottom of a fraction. Just mathematically, you cannot divide by 0. So what we have to include here when we say this, we have 2x over negative x plus 5, but we have to also include what's called the excluded value. So x cannot equal, that's what this symbol means here, cannot equal 5. Because if I put 5 in here for x, what happens? Negative 5 plus 5 is 0. We can't have that. So when you do this with the division, you have to make sure you find out if there's an x in the bottom of your fraction, what x cannot equal, and you have to make note of that there. Okay? Alright, let's look at a few examples here. First of all, addition. Here are two functions, f of x and g of x. And so again, if we have f plus g of x, we're just adding the two functions together. So this will be f of x, which is this one, 3x squared plus 7x, and then we will add to it the g function, 2x squared minus x minus 1. We're just going to add those together and then combine the like terms, and so 3x squared plus 2x squared is 5x squared. 7x, that was these two. 7x minus x is 6x. And then minus 1. So that's what we get when we add those. By the way, I didn't mention this before, but this is, I'm trying something new here today. I don't know if you noticed yet or not, but my screen is like a wide screen. I figured out how to do widescreen. So hopefully you can see this whole screen, and hopefully maybe it makes it a little easier to see. If not, let me know and we'll have to change some things around. But I think this will be better. Alright, f minus g of x. So again, we're going to do the same thing here. We've got 3x squared plus 7x. But this time we are going to not add but subtract the other function. Now this time, you notice before I just added them. I didn't worry about the parentheses here because it wouldn't make any difference. This time the parentheses make a difference because since I have subtraction here, I have to distribute that negative. Okay, so let's distribute the negative. I've got 3x squared plus 7x minus 2x squared minus a negative is plus x minus a negative is plus 1. And then we just combine the like terms like we did up here. This time we have 3x squared minus 2x squared, which is 1x squared. And I have 7x plus x is 8x, and then plus 1. There we go. So that would be what's left after I subtract those two functions, x squared plus 8x plus 1. Okay, so far pretty easy, right? All right, multiplying and dividing. Okay, same kind of things here. Now, if it says f times, this is supposed to be multiplication. It's maybe a little big for multiplication, but that's multiplication. So we're just going to multiply the two together. So that means I'm going to have here 3x squared minus 2x plus 1 times x minus 4. So when we're multiplying a trinomial times a binomial, we just make sure we distribute this x to everything and the negative 4 to everything. That's all we need to do there. So I'm going to go x, x times 3x squared is 3x to the third. X times a negative 2x is minus 2x squared. X times 1 is x. And then we do that with negative 4. Negative 4 times 3 is negative 12, x squared. Negative 4 times a negative 2x is plus 8x, and negative 4 times 1 is minus 4. Combine the like terms. So I've got 3x to the third, nothing else there. I've got a couple of x squareds there, so that's going to be minus 14x squared. And then I've got positive x and a positive 8x, so 9x, and then lastly minus 4. Okay, so that's it. So we're just multiplying. Again, we have done this kind of multiplying before, so it shouldn't be too bad. Very last one here for this stuff. We've got the f function on top, so 3x squared minus 2x plus 1 over the g, x minus 4. That's all we have to do here, with one exception. We have to tell what x cannot be. So what is the value of x that cannot happen down here? It's whatever makes this a 0 on the bottom, which means we would say x cannot equal 4. So this would be what our answer would look like. Again, as far as the the rest of the stuff, this one's actually the easiest one here. We don't actually have to do any work like we did up here. We just write the f over the g and just tell what's excluded. Okay, so that's the first part of this lesson. Shouldn't be too bad. Okay, but wait, there's more. It's going to get a little bit more challenging here, so you knew it was coming, right? All right, composition of functions. This is the second half that we have to talk about, composition of functions. This is a little bit trickier. Basically, what this is, a lot of times you'll see they'll write it like this symbol here, this F, and then this open circle and the G. It looks like fog, kind of, like, oh, fog. How this is pronounced is F of G of X. F of G of X is how you would say that. And they do a good job here, again, of kind of rewriting this. This is how to really think of this. If you think of this as F of, and then brackets, G of X, well, basically that just means you're taking the G function, the G of X function, and plugging it into the F function, okay? So kind of the pattern that you're going to do here is when it's written this way, and we'll do a few examples here, f of g of x, you're gonna take, remember when we'd write stuff, remember the domain are the x values, right? Okay, what happened? There it is. The domain of g would be your x values. So you're going to take your x value for g, plug it into the g function, and to get your range, which is g of x. That's your y value. Then you're going to take the y value from that function and plug it into f, and then see what you end up with at the end. So it's kind of several steps there. It's a little tricky, but this, you know, let's just do what we can. We'll do a few examples. They'll probably make a little bit more sense. Maybe not, but we'll do what we can. All right, here are your functions. Now there's two different ways we're going to be able to do this. One is where you're just given a set of ordered pairs, and then, which this is probably the harder part to do, and then the second part is where we've actually got a function, you know, equation that we plug in, and that's a little bit easier. So this is probably in the whole lesson, this is the hardest part right here. All right, so here's f of x, ordered pairs, g of x, ordered pairs. We're trying to find f of g of x, okay? All right, so remember again what this means is, let me write it over here. We're trying to find f of g of x, okay? So when we're trying to find this, f of g of x, let's start with the g of x, okay? So we're just going to work our way through. We're going to start with the x value on each of these. All right, so first of all, g of x, the x value is 7. So let's see, how should I do this here? If the x value is 7, and then in the g function, what's the y, or the g of x, which is 0, right? Okay. And this is, I should have left myself a little more room here, but this is in, let's say this is in the g function here. That's a g. Okay, so we said the x was 7, which means the y is 0. So then what I'm going to do is I'm going to use the y, the 0, remember, because that's what g of x is, and I'm now going to plug that into the f function. Okay, so I'm going to go up to my f function and see, I'm going to use this. Let's see here, to keep this the same here. So I'm going to take that y from here, and I'm going to plug it into f, and I'm going to say, is there a 0 up there? Yes, there's a 0 for x in the f function. So that means I'm now using the y from the g as the x for f. And what is the number that goes with the x? The y that goes with that is -1. That's your y. Okay, like I said, this is a little confusing, but basically I started with the g. I started with the 7, which is x. I found that the y is 0. Then that is what I'm going to look for in f, and there it is. There's the 0 in f and the -1 that goes with it. So as a result of all of this, what I end up with is the original x that I started with, the ordered pair of 7, and the y is -1, the y at the all at the end. So when I do this composition, I start with this x, and I end up with -1, so 7, -1. And then I just have to do that for each one of these. So again here, let's go to the next one. -1 on g has 7 as the y. So now let's go up to the f. Is there a 7? Yes, 7. So then we can plug 7 in for that, and what goes with that one is 7. So what do I end up with on that one is the first one, -1, and the last one, 7. Now let's go to the third one. I got 4 here that I can also look at. 4 goes with 9. Is there a 9 in the f? 9, there's a 9, so that means we can plug it into the 9 into f, and what goes with that is 4. So what I end up with here at the very end is the first x and the last y, which is 4, 4. And then finally, one more we can look at. We can look at the 8 here. You just look at each x in here. And so then on this one, you got 8. What goes with that is 2. Now go up to the y, or the f of x. Is there a 2 there? Yes. So we can plug that one in, and what goes with that is 6. And so in the end, it's 8 and 6. And so f of g of x are all these points. And of course, then remember the domain are the x values. So what's my domain here? 7, -1, 4, and 8. And the range would be all the y values, -1. That's a horrible squiggly bracket. -1, 7, 4, and 6. Your domain and range. Okay? I know. Okay, I know. Let's do another one of these here. Maybe it'll be a little bit better. We're going to do that same thing, but instead of f of g of x, we're going to do g of f of x. We're just going to switch it around, okay? So let's see how this works. It's all the same numbers, but notice this time it's g of f of x. So that means it's g of f of x. So this time we start with the f function, okay? So it's going to kind of work the same way. We're going to start with the f of x, or the f function here. So let's start with the f, and we're going to start with all the x's that are in f. So what are the x's here? We're going to start with, we got 2, and I'm going to do this slightly differently. We got 2, 9, 7, and 0, right? So I'm just going to start with, going to kind of preload those. All right, so we're starting with the f function. When x is 2, what's y? Y is 6. Okay, then remember what we're going to do is then we're going to plug it into the g function. So we're looking for a 6 here. You go, oh, look at this. In g, there is no 6 for x. It doesn't work, does it? So basically, in this one here, they just make sure I see the right. I believe that's undefined is what they call that. Yeah, I can't find it there. But basically, it doesn't work. Okay, so this one at this level here, since we did not have 6 as an x here, we can't continue that anymore. So we can't do that. That will not be included in our answer. Okay, let's go to the next one, 9. Okay, what goes with 9 is 4. Now let's look to see, is there a 4 in the g function? Yes, there is. So we can continue on 4. And what's the 4? What goes with the 4 is 9. So our ordered pair here is the first x and the last y, 9, 9. 7 in f has a y of 7. Is there a 7 for x in the g function? Yes, there is. So we can use the 7 there, and what goes with that is 0. And so our final ordered pair is the first x and the second y. So 7, 0. And then finally, the 0, what goes with that is -1. And then is there a -1 for g of x? Yes, there is. Here it is right here. So we can use that one, and what goes with it is 7. And so again, the ordered pair would be 0, 7. The first x and the last y. So this would be my g of f of x, and then domain would be your x values, 9, 7, 0, and your range would be 9, 0, 7. Sorry, I didn't make a squiggly bracket there. Okay, and there's your domain and range. We will work on this more, so, you know, if you're still not sure about it, that's okay. We'll work on it more. Like I said, that's probably the hardest part. We got one more thing to look at similar to this, but it's actually, I think, a little easier. Okay, so again, it's the same thing. We're trying to find f of g of x. Whoops. F of g of x. But we've got not ordered pairs. We have a whole equation here. Okay, we got a whole function equation and another function equation here. And so what we're going to do on this one, though, is then we're basically going to kind of do the same thing. This really means, where's my thing here? You know, f of g of x. And I like to write it like this because it helps me see kind of what goes where. So what this means is, remember, g, and like in this case, look at g of x. That's 2x minus 1, right? Okay, that's what g of x is. So what I'm going to do here is that means I'm really trying to find f of whatever g of x is, which is this whole thing, 2x minus 1. And if I'm trying to find f of 2x minus 1, what does that mean I do? Everywhere in the f function that there's an x, I put 2x minus 1. So in this case, it would be, and this, we've kind of done stuff like this, so that's why this isn't quite as bad. So 3 times 2x minus 1 squared minus 2x minus 1 plus 4. We've just kind of done some stuff similar to this, right? It's just that you have to get it started out correctly, where whatever g of x is, you take that whole function there and plug it in for each x in this function. And then you work this out. Okay, when we have a binomial squared, what do we have to do? Did you say write it twice and FOIL it? That is correct. That is correct. So we've got 3 times 2x minus 1. 2x minus 1, we'll FOIL that. Distribute this negative here. Let's just go ahead and do that, get that out of the way. Minus 2x plus 1. Negative times the negative is plus 1. And then we have plus 4 here at the end. So now I just have to FOIL these together and then combine the like terms. Oh, I have to FOIL these together, then distribute that 3. Don't forget about that 3 out front. 2x times 2x, 4x squared. 2x times the negative 1, negative 2x. Negative 1 times 2 is another negative 2x. Negative 1 times negative 1 is plus 1. We'll combine those like terms there. So this is really 4x squared minus 4x plus 1. All times 3. And then, of course, don't forget about this stuff here. It's still minus 2x. I'm going to combine 1 plus 4 is 5 there. And then distribute the 3 here. So this is going to end up being 12x squared minus 12x plus 3 minus 2x plus 5. One more step. Combine the like terms. So I have 12x squared. Negative 12x and negative 2x is negative 14x. So we've used that, and what's left is 3 plus 5, which is 8. So we would leave our answers at 12x squared minus 14x plus 8. Okay, again, I don't know. I think this is a little bit easier than the stuff with the numbers, but you're just plugging the g function into the f function there. And then, yeah, let's see. I don't think, let's not worry with the domain and range on this. Let's just find the composition function here. Okay, so let's move on. Last one. Last one, same 2 functions, but this time it's g of f of x. So again, remember that means g of f of x is how that would be written. And so that means you're going to take the f function and plug that in for each x in the g. So in this case, f of x is all of this right here. So I'm going to try to find g of 3x squared minus x plus 4. And so what that means is wherever there's an x, I'm going to plug in this whole thing. And so over here it's 2x minus 1, so that's going to equal 2 times x, which is now all of that stuff. 3x squared minus x plus 4 minus 1. So this is my new x. So in this case, all I have to do is just distribute the 2. 6x squared minus 2x plus 8 minus 1 combine the like terms, which in this case would be 6x squared minus 2x, and then 8 minus 1 is 7. Okay? So that would be our composed function there, g of f of x. So I think that last part is a little bit easier. You're just plugging one function in for x and the other one, and vice versa. It's the one with the numbers is toughest, and we will spend more time on that in class. But that's going to do it for section 6.1. Thanks for being with me, and hopefully this widescreen thing works good for you. If not, I'll switch back, but if it works good, we'll stick with it. So, all right, thanks a lot. We'll see you next time. Bye.